Welcome to CyberExplain channel. Today we are going to discuss SailPoint versus Saviynt, IGA deep dive for pros. Hey everyone, welcome back to the channel. Today, we are jumping into a topic that gets a lot of enterprise security folks thinking: identity governance and administration, or IGA. Specifically, we are putting two of the biggest names head-to-head, SailPoint and Saviynt. Forget the flashy brochures. We are going to dissect what these platforms really do under the hood, look at how they handle tricky situations, and what pitfalls you need to watch out for. This is for those of you who have moved past the basics and are ready for a deep dive. So grab your coffee, settle in, and let's get started. Before we pit them against each other, let's quickly frame what we are even talking about. At its heart, IGA is about managing who has access to what resources, and ensuring that access is appropriate and compliant. Think of it as the ultimate bouncer and auditor for your digital kingdom. It's more than just provisioning accounts, it's about the entire life cycle of access, from granting it initially, through regular checks, to revoking it when it's no longer needed. We are talking about automating these processes, which is critical in large, complex environments. One of the core functions of any IGA tool is provisioning. This is essentially the process of creating, updating, and deleting user accounts and their associated permissions across various applications and systems. Imagine a new employee joining your company. Instead of someone manually going into Active Directory, then Salesforce, then Workday, an IGA tool can automate all of that based on their role. This isn't just about speed, it's about consistency and reducing human error, which is a massive attack vector. The protocols here can range from SCIM for cloud apps to direct database connections, or even older RPC methods for legacy systems. Then there's access certification, often called access reviews or attestation. This is where managers or application owners periodically review who has access to what and decide if it's still necessary. Think of it like a bank manager needing to review every employee's keycard access to different vaults every quarter. It's a compliance requirement, but also a vital security check. IGA tools automate the generation of these review campaigns, present the data clearly, and track the decisions. This process helps catch permission creep, where users accumulate access they no longer need. Segregation of duties, or SOD, is a big one, especially in regulated industries. It's about ensuring that no single individual has control over all parts of a critical transaction. For example, you don't want the same person who can create a vendor in your ERP system to also be able to approve payments to that vendor. This prevents fraud and errors. IGA tools are crucial here for defining SOD policies, identifying conflicts in current access, and even preventing users from being assigned conflicting roles in the first place. This often involves complex rule engines that analyze combinations of permissions. Now, let's talk about SailPoint. They've been in this space for a long time and are widely recognized as a leader. Their platform, Identity Now for SaaS and Identity IQ for on-premises hybrid, is known for its robust functionality across provisioning, access governance, and SOD. They often integrate deeply with HR systems to drive provisioning workflows, which is a huge plus. Their architecture is generally considered mature, with extensive connectors for a wide array of applications, both cloud and on-prem. They've built a strong reputation for handling complex identity environments. SailPoint's main advantages often lie in its comprehensive feature set and its deep experience with large enterprises. If you have a very complex ecosystem with a lot of legacy applications, SailPoint often has the connectors and the flexibility to manage it. Their access certification engine is powerful, and their SOD capabilities are second to none for many organizations. They're particularly strong in environments where identity is tightly coupled with HR processes, driving automated onboarding and offboarding based on employee status changes. They also have a well-developed marketplace for governance policies and connectors. However, SailPoint isn't without its challenges. One of the most frequently cited limitations is its cost. It's a premium solution, and for smaller or mid-sized organizations, the licensing and implementation costs can be prohibitive. Deployments can also be lengthy and resource-intensive, often requiring significant professional services. The complexity of the platform means that organizations need skilled personnel to manage and maintain it effectively. While it has broad capabilities, sometimes achieving very specific or niche governance workflows can require custom development, which adds to the time and cost. Now, let's look at Saviynt. They've positioned themselves as a modern, cloud-native IGA solution, often built on a more unified platform. Saviynt often touts its integrated approach, combining IGA with application governance and even risk management capabilities. Their architecture is generally seen as more streamlined for cloud environments and often leverages AI and machine learning for anomaly detection and better risk scoring. They aim to simplify the deployment and management of identity governance, particularly for organizations heavily invested in cloud services like Microsoft Azure and AWS. Savynt's key strengths often revolve around its agility and its forward-looking features. Because it's built with a modern architecture, many find it easier and faster to deploy, especially in cloud-forward organizations. Their AI capabilities can provide more proactive insights into access risks and unusual user behavior, going beyond traditional rule-based SOD. The unified platform concept means you might be consolidating multiple functions into one tool, potentially simplifying your tech stack. They are also strong in integrating with modern SaaS applications and cloud infrastructure services, offering granular controls there. On the flip side, Saviynt, being a bit newer than SailPoint in some areas, might have a less mature connector ecosystem for very old or niche on-premises applications. While their AI is powerful, understanding and trusting its outputs can be a learning curve for security teams. The unified platform, while an advantage, can also mean that if a specific module isn't as mature as a dedicated function tool, you might feel that limitation. And like SailPoint, it's a significant investment, so cost is still a consideration, though perhaps with different pricing models that might appeal to cloud-centric businesses. This brings up an interesting architectural point. SailPoint and Saviynt are primarily *dedicated *IGA solutions. They are purpose-built for identity governance. However, you also see identity governance capabilities being *built into broader suites, like Microsoft's Entra ID, formerly Azure AD Identity Governance, or features within security platforms from vendors like ServiceNow. These suite-integrated solutions can offer a more seamless experience if you are already heavily invested in that vendor's ecosystem. The trade-off is often that their IGA features, while improving, might not be as deep or as flexible as a dedicated IGA tool for highly complex, multi-application environments. Let's ground this with a real-world scenario. Imagine a large, traditional bank. They're running quarterly access certifications and critically need to enforce segregation of duties across hundreds of applications, core banking systems, trading platforms, HR, finance, you name it. They're trying to decide between SailPoint and Saviynt. The bank's IT and security teams are already stressed with compliance demands. They need a solution that can accurately identify SOD conflicts, automate the review process, and integrate with their complex, hybrid IT landscape. This isn't a simple buy-and-click decision. For this bank, SOD is paramount. They need a tool that can model complex, multi-application SOD rules. For instance, a rule might state that an individual cannot initiate a payment in the treasury system and approve that same payment in the general ledger system. This requires the IGA tool to understand permissions across disparate applications. They'll also need robust reporting to demonstrate compliance to regulators. The sheer volume of applications means integration speed and the breadth of connectors will be a major factor in their decision. This is where the nuances between SailPoint's mature connectors and Savynt's modern integration patterns become critical. Beyond SOD, provisioning is key. When a new trader joins, they need access to trading platforms, market data feeds, and compliance tools * immediately start. Conversely, when someone leaves, all their access must be revoked instantly to prevent breaches. The bank likely has a mix of cloud-based trading systems and older, on-premises financial applications. The IGA tool's ability to integrate with their HR system for triggering these events and then reliably provision their provision across this hybrid environment will be a deciding factor. This speaks to the strength of SailPoint's HR integrations versus Savynt's cloud-native provisioning strengths. The quarterly access certification process at this bank could be a massive bottleneck. Imagine thousands of managers needing to review hundreds of access rights each. The IGA tool needs to present this information in a clear, actionable way with context. It should help managers quickly identify what's unnecessary or suspicious. Both SailPoint and Saviynt offer sophisticated campaign management and analytics, but the user interface and the intelligence behind the recommendations, example, flagging dormant accounts or excessive permissions, can differ. The bank will look for a system that minimizes the burden on its busy managers. Now, let's pivot to the darker side: attacks. A common attack vector isn't necessarily breaking into the IGA tool itself, but exploiting its misconfigurations. Imagine an attacker finds an IGA tool where provisioning rules are too permissive, or sort policies aren't properly defined for a critical application. They could potentially use a legitimate user account and exploit these gaps to gain elevated privileges or move laterally. For example, if an IGA tool isn't correctly provisioning permissions for a cloud storage bucket, an attacker might exploit that to gain unauthorized access to sensitive data, thinking it's part of the normal provisioning process. Another attack pattern could involve credential stuffing or phishing, targeting accounts that have access to IGA-related systems or connectors. If an attacker compromises an administrative account with access to the IGA console or one of its service accounts used for connecting to target applications, they can cause significant damage. They could potentially modify access policies, grant themselves or others unauthorized access, or disable critical governance functions. The protocols used for integration, like API keys, auth tokens, or direct service account credentials, become critical points of compromise. We also can't forget insider threats. A disgruntled employee with privileged access to the IGA system could intentionally grant themselves or others excessive permissions, or even manipulate access certifications to hide illicit access. This is where robust auditing and logging within the IGA tool become absolutely critical. The ability to trace every change, every approval, and every policy modification back to a specific user and timestamp is non-negotiable. The access logs from the IGA tool itself become a primary source for detecting such abuse. How do we detect these kinds of issues? It often involves a multi-layered approach. Firstly, monitor the logs from the IGA tool itself. Look for unusual administrative activities, mass permission changes, disabling of SOD rules, unexpected provisioning events, or large numbers of access certification campaigns being completed too quickly or with too many auto-approvals. Secondly, monitor the target applications. Are there sudden spikes in activity from users who recently gained access? Are there access patterns that deviate from their typical behavior? Correlation of logs between the IGA tool and the target systems is key. User and Entity Behavior Analytics (UBA) tools can be invaluable here. If an IGA system is integrated with a UBA, it can flag when a user's access, provisioned or certified through the IGA tool, is suddenly being used in ways that are highly anomalous to their role. For instance, if a finance analyst's account recently granted access to a development environment through the IGA, suddenly starts making network calls typical of a system administrator, that's a huge red flag. This proactive detection can stop an attack in its tracks before it escalates. What happens when an IGA implementation goes wrong? We've touched on cost and complexity, but there are specific failure modes. One is when the IGA tool is implemented but doesn't actually enforce policies correctly. This can happen if the connectors are faulty, the rules are misconfigured, or the underlying data is inaccurate. The system looks like it's doing its job, but it's not, leaving a false sense of security. This is a critical failure mode because you might not realize the deficiency until an audit failure or, worse, a breach. Another major failure mode is the garbage in, garbage out problem. IGA tools rely heavily on accurate identity data, typically from an HR system. If the HR system is out of date, incorrect job titles, incorrect department assignments, delayed updates for terminations, the IGA tool will make bad decisions. It might provision access to terminated employees, assign roles incorrectly, or fail to deprovision access promptly. Maintaining the integrity of the authoritative source for identity data is as crucial as the IGA tool itself. A more subtle failure mode is over-reliance on automation without sufficient human oversight. While automation is the goal, blindly trusting every automated provisioning or deprovisioning event can be dangerous. There should always be mechanisms for exception handling and periodic review of automated actions. Also, if the IGA tool isn't regularly maintained, updated, and retuned as the IT environment changes, its effectiveness will inevitably degrade. It's not a set-it-and-forget-it solution. Let's look under the hood a bit more at the architecture. Connectors are the lifeline. Whether it's a REST API connector for a modern SaaS app, a JDBC connector for a database, or a custom connector for an old mainframe, the quality and robustness of these connectors are paramount. SailPoint and Saviynt both have extensive libraries, but the complexity of integration varies. Think about how these connectors authenticate service accounts, API keys, OAuth. Securing these credentials and managing their rotation is a significant architectural challenge and a potential attack surface. Consider SCIM, System for Cross-Domain Identity Management, for provisioning a user to, say, Office 365 or Salesforce. The IGA tool, acting as the SCIM client, would send a POST request to the target application's SCIM endpoint with the user's details, name, email, groups. The target app, SCIM server, processes this, creates the user and returns a success or error response. If it's an update, it might be a PUT request. The critical part is ensuring the SCIM implementation is robust, handles errors gracefully, and uses secure transport, HTTPS. Improperly implemented SCIM can lead to orphaned accounts or incorrect attributes being synced. For SOD, the protocol is less about network traffic and more about internal logic. The IGA tool builds an access model by querying permissions from various applications, often through their APIs or direct database access. It then compares these permissions against its predefined SOD rules. For example, if a rule says admin create and admin delete on resource X cannot be held by the same user, the engine scans the collected permissions for any user holding both. The protocol here is the internal data structure and the matching algorithm, which needs to be highly efficient and accurate to avoid false positives or negatives. Let's talk edge cases. Role explosion happens when you try to map individual permissions to meaningful business roles. This can lead to an unmanageable number of roles. Conversely, identity drift is when a user's actual access over time diverges from their assigned role, often due to manual overrides or ad hoc permissions granted outside the IGA system. Both SailPoint and Saviynt need sophisticated role management and reconciliation processes to combat these. Identifying and remediating identity drift is crucial for maintaining the integrity of your access controls. What if a critical application goes offline? How does the IGA tool handle it? If a provisioning connector relies on a live connection to that app, it might fail, halting onboarding or offboarding processes. Similarly, if access certifications rely on fetching current permissions from an unavailable app, those campaigns might be delayed or generate errors. Robust IGA architectures need error handling, retry mechanisms, and potentially the ability to work with cached data or fall back to manual processes when an integration point is down. The impact of system outages on IGA functions is often underestimated. Delegated administration is another tricky area. You might delegate the ability for specific managers to approve access requests for their teams. But how do you ensure those delegated admins are trustworthy and making good decisions? This is where audit trails and reporting become essential. You need to be able to audit the auditors. If SailPoint or Saviynt are used in a highly delegated model, the system's ability to log who did what and potentially flag suspicious approval patterns is vital for maintaining trust and security. When it comes to integrating with diverse applications, SailPoint often leverages a vast connector marketplace and a more established framework for custom connector development suited for deeply embedded legacy systems. Saviynt, with its cloud-native approach, often emphasizes API-first integrations and a more unified data model, making it potentially quicker to connect to SaaS apps and cloud platforms. The choice here often depends on the organization's existing application portfolio and its cloud adoption strategy. A bank with many on-prem systems might lean towards SailPoint's breadth, while a cloud-native tech company might prefer Savynt's agility. Let's be blunt, IGA is expensive. Beyond the initial licensing costs, which can be substantial for both SailPoint and Saviynt, you have implementation costs. These can run into hundreds of thousands, even millions, of dollars for large enterprises, often involving significant professional services from the vendor or third parties. Then there's the ongoing operational cost, the skilled personnel needed to manage the platform, the infrastructure to run it, if not fully SaaS, and the continuous tuning and updates. It's a long-term investment, not a quick win. Speaking of long-term, deployments of these enterprise-grade IGA solutions are rarely quick. For a large bank with hundreds of applications, a full deployment can take 12 to 24 months, sometimes longer. This involves phases like discovery, design, connector development, policy configuration, testing, user acceptance, and phased rollout. The complexity of integrating with diverse systems, mapping roles, and defining SOD rules across a vast application landscape contributes to these lengthy timelines. This requires significant project management and stakeholder buy-in. What often surprises people is the sheer underlying complexity. While the user interfaces for SailPoint and Saviynt are designed to be intuitive for end-users performing certifications, the backend architecture, the policy engines, the connector configurations, and the integration points are incredibly complex. Getting this right requires deep technical expertise. It's not just about clicking buttons, it's about understanding how the system models identities, how it interprets permissions, and how it enforces policies across a heterogeneous IT environment. This is where the true cost and challenge lie. To wrap up, let's revisit the dedicated versus embedded governance. For organizations with very diverse, complex application landscapes and stringent SOD requirements, dedicated IGA tools like SailPoint and Saviynt generally offer the depth and flexibility needed. If your primary systems are already within a single vendor's ecosystem, example, heavily Microsoft-centric, then their integrated governance features might be sufficient or at least a good starting point and potentially less complex to manage. It's a trade-off between specialized power and integrated simplicity. So, when faced with choosing between SailPoint and Saviynt for that bank scenario, or any enterprise, what are the key takeaways? Understand your application landscape. Is it mostly cloud, hybrid, or legacy heavy? What are your absolute critical governance requirements? Is it SOD, compliance reporting, or automated provisioning velocity? Assess your internal team's skill set and your budget. Don't just look at features, look at the total cost of ownership, the deployment timeline, and the vendor's roadmap. It's a strategic decision, not just a technical one. Both SailPoint and Saviynt are powerhouses in the IGA space, each with their own philosophies and architectural strengths. SailPoint offers a mature, feature-rich platform with deep integrations, often favored by large, complex enterprises. Saviynt brings a modern, cloud-native, AI-driven approach, appealing to organizations looking for agility and integrated risk management. Ultimately, the best choice depends entirely on your organization's unique context, technical environment, and strategic goals. There's no one-size-fits-all answer, but hopefully, this deep dive gives you the insights to make a more informed decision. Thanks for watching. Subscribe to the CyberExplain channel. See you on the next video.